Okay, so this is the second video, and what you may want to do is stop this here and draw the graphs of the different functions and then follow along, or just follow along, because since the graphs are already drawn, I'm going to go through this quickly, and I drew the graphs already just because to save time. So in A, so I'm going to state in words what's going on, and then on the next slide we're going to write down what's going on in each of these four graphs, and then we'll continue from there. Okay, so we can use our parent graph, in this case f of x equals 3 to the x, to describe various transformations. And in A, our parent graphs are all in red, so I kept them all in red. That's the parent graph, the 3 to the x. So we use that graph to make transformations according to whatever we're given. So in A, g of x, our new function, is 3 to the x plus 1. And what you can see is going on in that first picture is that we're having a shift to the left 1 unit. And it's always nice on your parent graphs. I'm sorry. That's not what I wanted. It's always nice on your parent graphs, that's not what I wanted either, my apologies, to plot a couple points and try to make them as easy and simple as possible, and sort of use those points to help guide you into your new graph, because it's more challenging when you're just sketching the parent graph in general and then trying to do a transformation. So it's much easier just to plot a couple points, and if you already know the shape of your graph, that's good, and then do the transformation. So in A, we're having a shift to the left 1 unit, and that's what's going on with A with that function, and we'll talk more about it algebraically on the next slide. In B, we have our parent function, and that's shifting down 2 units, and that's the function h of x equals 3x, this function, right? I have no idea what's going on, I'm sorry. But this function right here is h of x equals 3 to the x minus 2. In C, we have a reflection going on in the x-axis, and so for C, we have k of x equals negative 3 to the x, and in D, we have a reflection in the y-axis, and that's j of x equals 3 to the negative x. So these are some of the different transformations. Now I'm going to go to the next slide, which for you is basically the bottom of this page, and we're going to fill that in a little more detail of what I just stated. Okay, I'm sorry, I went too fast. Okay, so for A, we have, so g of x was equal to 3x plus 1. Algebraically, if you looked at this in terms of our parent graph, f of x, this is really f of x plus 1. Sorry. And so what happened is we shift to the left 1 unit. Okay, so I was trying to use the stylus and it wasn't working. Okay, for B, we had h of x equals 3 to the x minus 2, so that 2 isn't in the exponent. And what this represents is our parent graph minus 2. Okay, and for that graph, we shift down 2 units. For our C graph, that was k of x equals negative 3 to the x, and that equals negative f of x. And this is a reflection of f in the x-axis. And D was j of x equals 3 to the negative x, which equals f of negative x. And this was a reflection of f. And if you don't have room, you can put it on the side because I'm not going to write anything over there. And, oh wait, let me see. Hold on. C was a reflection in the x-axis, and D was is a reflection in the y. I just wanted to make sure I had it right. Axis. Okay, so those are some of your different transformations. And let's see, do I have anything here? Yes. So for your video quiz question number 2, you're going to use the graph of f of x equals 4 to the x. So first sketch that graph. That's your parent graph. And you're going to describe the transformation that yields the graph of g of x, which is equal to 4 to the x minus 3. So you're going to show it graphically by a picture, but also explain in words the type of transformation that's going on. And you can refer back to that previous example to help you out. All right, so we're almost actually have a couple more things I want to cover in this section and then we'll be done. So recall that E is an irrational. So now we're going to talk about E, the exponent, E, the number E, is a rational number that is approximately 2.718. Okay. And we're going to evaluate E, and actually you're going to do that, so I want you to finish that table. And this isn't part of your quiz, but just make sure for your notes, make sure you finish this in your notes. I'm just going to plot, because I'm still having trouble graphing on this, I'm just going to plot a couple points. One is like 2.78, so somewhere around, it still wants to act up. Okay, I'm sorry for all that noise, that's the stylus. So when you sketch yours, you'll have your points so you can be a little more exact. So this is our e to the x function. F of x equals e to the x. And so we're going to stop the video here. We're going to be talking a lot more with exponential with the e to the x function. For now, I just want you to know it's one of our special types of exponential functions. As you can see, the graph is similar to all the other general exponential functions, but this is a really special one that we'll be working more and more with, especially when we start talking about logarithmic functions. So I'm going to stop this and then go to the last section of our notes, which talks about applications of exponential functions.